Denominator.
Right here. So now when I cross them out, what do I put in their place?
Ones.
Ones. What's the next factor?
X minus 7.
Do I have an x minus 7 occurring anywhere?
No.
What's the next factor?
X minus 4.
Do I have an x minus 4 occurring anywhere in the denominator?
Yeah, they're on the bottom
You put
left.
cross them out, put ones in their place. So you're left with factors of ones. All right, so remember the next step. Now your final answer is going to be that one fraction. So you're going to write this product as one fraction and just write your factors. What's my first factor?
X plus 4.
Is going to be multiplied by x minus 7.
7.
Okay, that's the numerator. The denominator is going to be,
11.
yep, and that's it. There's your answer. So leave your answer factor. Don't multiply this out. Leave it like that. Now you can multiply it out, but you're wasting your time because that's really all you want anyway. You want to leave it in factored form. Okay, that was 16. All right, let's look at 38. 38. All right, 38. You have x squared minus y squared divided by 3x squared plus 3xy times, and then the second fraction, the second rational expression is 3x squared plus 6x divided by, and then the denominator is 3x squared minus 2xy minus y squared. All right, so those are your two rational expressions. Okay, what's the first step? Factor. Now at this point, since we spent a whole chapter on factoring, and we're still reviewing factors going along, you should get it better and better and quicker with this. What's the numerator going to be? The first numerator?
X minus y
Times,
x plus y.
because that's the difference of two squares. So x minus y times x plus y. The denominator, how do you factor that?
You got GCF,
Factor out the GCF. Factor out, and what's the GCF? 3x. And what do you have? 3x times what?
x plus y.
X plus y. Times. The numerator, the second fraction, what do you do?
GCF,
Which is 3x. You're left with
plus
x plus 2. All right, let's talk about the denominator. Now notice you have two variables, so remember how to do that. The GCF is 1, so go to the two binomials. What are you going to try?
3x and 8.
3x and x. There's only one possibility for the last, y and y. Last sign's negative, so the middle sign has to be negative. So which one's going to be negative, which one's going to be positive?
Does it matter?
Yes, it matters,
Oh.
because the on the inner have to be the negative.
Oh.
Oh,
And the second one.
The second one's negative. Okay. You can always check, because 3x times a negative y is a negative 3xy. Y times x is yx. When you subtract them, you get that negative 2xy. All right, so the first step is to factor. So you got to become proficient with factoring. All right, what's the next step? Divide common factors. What's the first factor?
X minus y.
Do I have one in the denominator?
Yes,
Yeah,
the bottom right.
Bottom right.
Put ones in their place when you cross them out.
X plus y. We got one on bottom left
Like
there.
that. All right, next factor is a 3.
3x.
No,
Oh, 3.
the actual, technically the factor's a 3. Because remember, factors separated by products. This times 3 times x, okay? Is there, can I reduce this 3 with anything else in the denominator? The 3.
3.
So those are ones. What's the next factor you see?
X.
I can reduce with that one. That's ones. What's the next factor you see?
X plus 2.
Is there one in the denominator?
No.
No. So what's the answer going to be?
X plus
X
2
plus 2.
divided by 3x plus y.
3x plus y.
And
the answer.
we, obviously, since it was broken down, when you factored it out, we don't have to leave it in parentheses like it is?
No, don't leave the parentheses off.
Okay.
The only time you want to leave it in parentheses is when you have something like this.
Okay.
Okay? All right, so notice his question was, do we need to put parentheses? No. It's best if you leave it off. Now, if you put the parentheses, leave the parentheses, I can't take points off, but that's not mathematically how we would write it. Here we need parentheses because you're really multiplying two binomials together.
But you also needed if there was a 3 before the x plus 2, right, to multiply
You mean
plus.
here? Yeah, you need parentheses there because you're
She
factoring.
was asking me, that's why I was just.
So,
Yes,
okay,
you're factoring. So remember when you're factoring, you left that parentheses there.
Right.
All right, you had to say 3 times and then parentheses x plus 2. If you left the parentheses off, then you're saying the only thing you're multiplying 3x by is this x, and that's not true. Okay? All right, now let's look at this. Okay, so remember 2 semesters ago when you had this. 2/3 divided by, let's say, 8/6. Well, let's do 8/15. 8/15. 2/3 divided by 8/15. What did you do last 2 semesters ago?
Reciprocal of the second.
You wrote the division as a
Multiplication.
multiplication problem. That's what you did. Now, to rewrite this as a multiplication problem,
2/3.
you kept the 2/3, you kept that first fraction the same, and you multiplied by the reciprocal of the fraction following the division symbol,
So it'd be 15/8.
15/8. So you went from a division to a multiplication, and then it's what you've been doing. So you reduce, 2 into 2 is 1, 2 into 8 is 4, 3 into 3 is 1, 3 into 15 is 5, so the answer would have been 5/4. Okay? All right, now that takes us to this now. So this is, let's do 20, let's not do that one just yet. Let's do, all right, let's do 26. So this is 26. So 26, you have m minus n squared divided by m plus n divided by m squared minus mn divided by m. All right, so that's a problem.
Do the same thing you do for reciprocal.
All right, first, now remember, we're dividing rational expressions. The first you want to do, step 1, when you're dealing with division, is change to multiplication problem. So, first step, change division to multiplication. So the numerator, the first fraction stays the same. Now say times what?
M over m squared minus n.
All right, now that takes us back to what we've been doing. So once you change the multiplication, what's the next step? Factor. The first numerator is already factored because m minus n squared means m minus n times m minus n. That's what that means. The denominator, can I factor m plus n?
No.
No. The numerator is a monomial, so I can't factor that, just leave it alone. So at this point, there's nothing I could factor. But look at the second denominator. How can I factor that?
GCF.
GCF, which is m. So m times m minus n. So the second step was to factor. First step was to change the multiplication problem. So you multiply by the reciprocal. Then you factor. And now reduce your common factors. What's the first factor I see? Do I see one anywhere? Yes, in the denominator. The next factor you see is m minus n again. Do I have an extra one?
No.
No. The next factor I see is an m
Yes.
right here, right? And that's it. You're done with the factors. So what's the answer? Yep, that's the answer. M minus n divided by m plus n. Okay? All right. 28. 28. It's not that difficult as long as you're good. I didn't say great. Good at factoring. X minus 3 divided by 2 minus x. So that rational expression is being divided by this one. So the second fraction is x squared plus 3x minus 18. And then the denominator is x squared plus 2x minus 8. Now, once in a while, there'll be someone that's going to cross out these x squareds. And they'll cross out these x's like whatever they see. Can you do that? Can you cross out the x squareds, put ones in their place?
No.
No, those are not factors. Remember, factors are separated by products. This is separated by an addition symbol. It's not a multiplication symbol. So, no, don't do that. Those are not factors. The x squared is not a factor. It's a term in the numerator.
First thing you gotta do is multiply and flip.
Yes, so step one, since this is division, you're going to change this multiplication problem. So you keep the first fraction the same. Then say times the reciprocal of the fraction that follows the division symbol. So it's a numerator.
X squared plus 2x minus 8.
The denominator?
X squared plus 3x minus 18.
Okay. All right, now what's the next step?
Factor,
All right, in that first fraction, can I factor anything?
no,
No. Second fraction,
different story.
so whenever the coefficient of x squared is 1, that's the easy kind, people. So you need to be able to do this very quickly and correctly. So what's the numerator?
X plus 4, X minus
Nope. Oh, yes. Yep. All right, good. The denominator?
2, X plus 6, X minus 3.
So x plus 6 times x minus 3. And again, notice how quick some of you are doing it. That's the way you need to do it at this point. You get quicker and quicker as you go along through this. All right, now we're going to reduce the common factors, divide out the common factors. What's the first factor you see?
X minus
Do
3.
you have one in the denominator?
Yes.
Yes. What's the next factor you see?
Plus 4.
Do you have one in the denominator? No. What's the next factor you see?
X minus 2.
Do you see one in the denominator?
No.
No. I'm done? None? Okay.
X minus 2, you can take out the negative.
All right. So some of you remember the idea of opposites. Okay.
Yeah,
So x minus 2, its opposite is what? 2 minus x. Okay. We talked about opposites several days. 2 minus x. So remember, when we divide opposites, we're going to rewrite the numerator. Well, first of all, we divide opposites. What's that final answer?
a negative.
Negative 1. 5 divided by negative 5 is a what? Negative 1. 6 divided by negative 6 is a what? Negative 1. X minus 2 divided by 2 minus x equals what? Negative 1. But when we cross them out, we tend to put what here?
A 1.
No. We tend to. It's better to put what here?
Negative 1.
Negative 1, and put what here?
Negative 1.
1. 1. Negative 1 divided by negative 1 is not negative 1.
Look like he was
So-
about to swing on you.
He's lucky he went 3 feet closer. All right. So remember, in section 7.1, that's due next class period, you have some opposites involved. So remember, you're going to put negative 1 in the numerator, 1 in the denominator. All right. Now, before we... Now, there's several ways you can write that final answer. So you could say negative 1 times what?
X plus 4.
Divided by x plus 6. Just like that. That's fine. In my math lab, though, the way they're going to write it will be like this. Now remember, in my math lab, if you write this, it's fine. It's still correct because in my math lab they put all the different possible answers that could be correct. So that's fine. But remember last class period and the period before that, we talked about this. We talked about -6/5 being the same as 6 divided by -5. Or we can write it as -6/5, where that negative's out in front.
Right.
Okay? The way that my math lab, they're probably going to have the answer written is this right here is the same as x plus 4 divided by x plus 4 with what in front of this fraction? A negative. Okay? Now,
Understandable.
if any of you went from here to a step that looked like this, now remember, this is the way I would have written it like this. But if any of you did this, and remember all these are correct. If any of you said, well, I'm going to distribute the -1 because it's just -1, and you wrote it as -x minus 4 divided by x plus 6, that's fine as well. Any of those is fine.
You answered our question.
Okay? Any of those is fine.
Okay.
All right? Okay, that was 28. Okay, let's look at 48. 48.
Before you move on past that, can you change that 2 minus x to x minus 2?
No.
Once you take out the -1?
Oh, now, okay, now her question is this. Her question is right here. Could you have done this? All right, so remember the next step was to factor? So remember we said, we discussed that the first rational expression we could not factor.
Correct.
The second we could. But what she wanted to do though was, now you can factor anything. You can factor these binomials by taking out a -1 if you want to. So what she wanted to do was she noticed that, now I'm hoping you probably factored this first and realized there were opposites. Okay, so what she did was she factored this first, and you got, what was it, x plus 4x minus 2? And this was x plus 6, x minus 3. She realized that these were opposites. And so rather than doing what we did, and cross this out, put -1, cross this out, put 1, and we talked about that. The first time we talked about it was we discussed that, well, since they're opposites, that means that I can factor out a -1 from here. So if I rewrite 2 minus x as -1 times some binomial, -1, now the way you want to write this is this, -1 times what's a negative x?
X.
Positive x. -1 times what's a positive 2?
-2.
And so notice these are what? The same. So you got a 1 and a -1. So she's putting the -1 in the denominator. And then these divided out. And so what she would probably have would be this. So she would have x plus 4 divided by -1 times what?
X plus 6.
X plus 6. So that's what she would have probably had. Or you can take the negative and put out what? In front. Just like that. Or you could distribute the negative and have this instead. X plus 4 divided by what?
-x.
Minus 6. So again, all these things I have circled here, and here, they're correct. They're the correct answer.
You might want to circle down the bottom, just for,
So all these, that's a negative here. So all these 6 things, those could be an answer, depending on whether you put the negative in the numerator or the -1 in the denominator. But notice she wanted to factor out the -1 in the denominator first. But at first, what I thought she was going to say was, is 2 minus x and I rewrite as x minus 2? No, as long as I was what in front? A -1. All right, but that's a good question. All right, 48, you have this. You have 36n squared minus 64 divided by 48 divided by 3n squared minus plus 10, that's a 10. 10 n plus 8. So this rational expression is being divided by this rational expression, which is 3n squared minus 13n plus 12. And the denominator is n squared minus 5n minus 14. So n squared minus 5n minus 14. Okay. What am I doing to those two rational expressions? Dividing. What's the first step?
Multiply.
Change it to multiplication. So the first fraction stays the same. And so I change the division to multiplication, but to do that, I've got to do what to this fraction following the division symbol? Take the reciprocal. So the numerator is going to be n squared minus 5n minus 14. The denominator is going to be 3n squared minus 13n plus 12. All right, so that's where I'm at. Okay, once you change to multiplication, what's the next step? Factor. How can I factor that first numerator?
You got 6n minus 8.
Okay, so you want to say 6n, and that's fine. I'm going to go with what you're saying. Although technically that's not being factored correctly, but I'm going to go with what you're saying because it looks like it's a difference of two squares, right? And as we talk about it, I want you to notice that technically it's, if the direction is only factor this numerator, you would get it wrong. 6n minus 8, 6n plus 8, correct? Now you know it's wrong because what do you notice about 6n minus 8?
That you could get a 2.
You can factor out a 2. You know this is wrong also because 6n plus 8, you can do what? Factor out a 2. All right? So most of you probably would have done that. So let's keep on with this and see how we can fix it. So I'm going to leave it like this for right now. What's the denominator?
3.
You need to be proficient with this. GCF is 1, so 3n, n, possibilities for 8.
2 and 4.
Let's try 4 and 2. Where do you want to put the, and you want to get a 10 in, so where do you want to put the 4 and the 2? The 4 in the first one, 2 in the second, because 6 and 4 is 10. No, negative, they're both what? Positive. Positive. All right. Times? All right. What about this one?
N.
N. 14. 7, 2. Last sign's negative. And you want to a negative 5n, so which one has to be negative? 7. Okay. So n minus 7, n plus 2. The denominator? 3n and n. Now remember, the first thing you need to do is look for GCF. Okay, but the GCF is 1. Yeah, 4 and 3, 6, 2. You want to try 4 and 3? So I know I can't put the 3 here, because that means that all these I can factor out a 3 and it can't. So let's try the 4, the 3. Last sign's positive. These will be the same sign. They both begin negative. But let's check. I need a 13 in, right? The outer is 9, negative 9. The inner is a negative 4. And I do get what? Negative 13. All right. So I factored correctly. All right. Here's what's going to happen. So you're going to see how you factored the first numerator. So you're going to say 6n minus 8. Is there a 6n minus 8 in the denominator?
No.
Nope. So then you're going to say, all right, I'm going to go to the next one. 6n plus 8. Is there a 6n plus 8 in the denominator?
No.
Nope. Then you go to the next one. N minus 7. Is there n minus 7 in the denominator?
No.
Nope. You go to the next one. N plus 2. Is there n plus 2 in the denominator?
Yes.
Yes. So then you're going to say, all right, the answer is going to be 6n minus 8 times 6n plus 8 times n minus 7, all divided by these three things, right? And you're going to be very upset. No, it could still be right. You can have all these factors in there. So there's a possibility that you could have a problem where only one of the factors divide out. Okay.
Yeah, that's just
But-
a lot.
But you're not going to get full credit for this because you didn't factor correctly. when I asked you to factor the numerator, you were supposed to look at GCF first. What's the GCF?
8.
GCF is not 8. 8 doesn't go into 36 evenly.
Oh,
GCF is 2.
2. Okay.
GCF is 2. So what you needed to do first was factor out a 2. 2 times what?
2 times 18 n.
Squared minus 32. So the GCF was not a 2. Because what do you notice about 18 and 32?
They're even.
They're both even, so they're both divisible by 2. So the GCF was not a 2. What's the GCF?
No.
6 doesn't go into 64. 4. GCF is 4.
Because 4 goes into 36 9 times.
Yeah. 9 times, so 9n squared minus what?
16.
16. And now, what do you notice about 9n squared minus 16?
That's
Difference
Difference
of
of 2
two
squares.
squares. So how can I factor 9n squared minus 16?
3n minus 4.
Times?
3n plus 4.
That's what you should have written right here. That right here, this right here, I'm crossing this out, should have been this. So notice what happens when you don't factor completely. So that should have been 4 times 3n minus 4 times 3n plus 4. That's what that should have been.
You might want to, I guess we're going from this point, we might want to rewrite everything so that it's neater.
You could. You have plenty of time to do these problems, so you can write them out and erase them, write them out and erase them. You have plenty of time. But for me, I don't have that luxury of time.
3n.
I don't have that luxury, but you do.
I'm full of savage.
You only have one paper to write, so you have all that time. All right. Now, the first factors of 4, is there a factor of 4, or can that 4 be reduced to anything down there?
No.
No. The next factors of 3 and minus 4. Do you have one down there?
Yes.
Yes. Now you see it. The next one's 3 and plus 4. Can I reduce that? Yes. Next one's n minus 7.
Yeah.
No.
Sorry, I was looking at the,
Next one's n plus 2.
yes.
Now you can tell me the correct answer. What's the correct answer? 4 times n minus 7 divided by n minus 3. Okay? So notice what happens when you didn't factor completely. That numerator got some of you. You factored the rest fine, but that numerator got you. That first numerator. Now, that's how you leave the answer. Leave it in factored form. But if you, for some reason, wanted to distribute the 4, that's fine. So you could say 4n minus 28 divided by n minus 3. Nothing wrong with that, although we tend to have the final answer in factored form. Okay? So you really want the final answer in factored form. Leave it in factored form. Leave the final answer in factored form. Now, there will be times when you may just multiply it out. That's still correct, but leave it in factored form. That's how we prefer the answer written. All right, so it's 48. And then let's look at, let's see, let's do 56. 56. Let's look at 56. All right, 56. You have 9y divided by 3y minus 3 times y cubed minus 1 divided by y cubed plus y squared plus y.
Factor y.
9y, the y cubed minus 1. So 9y, 3y minus 3, y cubed minus 1, y cubed plus y squared plus y. All right, what's step 1 here? Factor, because it's already written as a multiplication problem.
Yes.
So factor. The numerator is a monomial, leave it alone. How can I factor that denominator in that first rational expression?
Factor out of 3.
Factor out of 3. GCF, factor out of 3. So I have this so far. I have 9y divided by 3 times y minus 1. Correct? Okay. Times. How do I factor the numerator of that second fraction?
Got a
The
difference
numerator.
of cubes.
Difference of 2 cubes. So I'm going to go off to the side. I'm going to go off to the side. I'm going to factor the difference of 2 cubes. This is difference of 2 cubes because I can fill in these parentheses. What goes inside that first one? What goes inside the second one? So there's your F, there's your L. So in factoring the difference of 2 cubes, you say F minus L, so that's going to be what?
Y minus 1.
So it's a binomial times the trinomial. So the trinomial part, the first term is F squared. So what's that?
F.
Y squared plus the product of F and L. So what's that? Y plus L squared, 1. So that's the numerator. So y minus 1 times y squared plus y plus 1. All right. So the numerator was the difference of 2 cubes. What about that denominator? How is the denominator the difference of 2 cubes?
Oh, no, you can factor out a y.
You can factor out a y. Did you say F is y? And you know it can't be the difference of 2 cubes because the difference of 2 cubes is 2 terms. The denominator had how many terms? 3. It had 3 terms. Okay, so factor out a y. Now when I factor out a y, I want you to notice something. That's y times what?
Y plus 5 plus 1.
And don't try factoring out that y squared plus y plus 1 because it's already listed in the numerator.
Right.
And besides, you can't factor y squared plus y plus 1. It's not factorable. All right, so that's all I can do right this at that point in terms of factoring. Now let's go through the factors. What's the first factor you see, and tell me correctly what's the first factor? 9 is the first factor. Will 9 reduce with any factor down there? The 3. So 3 into 3 is 1. 3 into 9 is 3. Okay? What's the next factor you see? Does that y reduce with a factor y anywhere in the denominator?
Down the bottom right.
Yeah, just at one place right here. So y into y is 1, y into y is 1. What's the next factor you see?
Y minus 1.
Is there one down there?
Down there, yeah.
Yes. What's the next factor you see?
Y squared.
Y squared plus y
Yeah, the whole
plus
thing.
1. You see one down there, right? You're done. What's the answer? Just 3. 3 over 1, which is just
Yeah.
3. Okay. All right, let's do one more. So that was 56. Let's look at 58. 58. Okay, 58. So again, in order to be successful with this, you have to know how to factor. So you need to use your time to factor. All right, x cubed. So instead of going to the movies or watching Netflix, and you need to be doing this and just take off 2 hours of sleep.
We're doing your homework for the class.
Oh, wow. I thought it was just going to be x squared plus like 27.
All right, that's divided by, and then x squared minus 9y squared, and then x squared minus 3xy. All right.
Watch your slides, please.
Okay, so that's what we have. So we do have a division. So the first step is to change it to multiplication. All right, so times, so change division multiplication, so we got to take the reciprocal of the fraction following the division symbol. So the numerator is going to be x squared minus 3xy. The denominator is x squared minus 9y squared. All right. How do I factor that first numerator? That's an x squared right here.
The sum of two cubes,
That's the
right?
sum of two cubes. So let's go off to the side and kind of figure out what that is. So actually, with the cubes and the difference in sum of two cubes, you may want to actually do the work. So x and what? 3 what though?
X plus 3y.
X and 3y, right? It's not just 3, it's 3y. So here's my f, here's my L. So remember, the sum and difference of two cubes is a binomial times a trinomial. So what's your binomial for this one?
X squared.
No, binomial,
Oh, x plus 3.
x plus 3y. The trinomial will be f squared, so it'll be x squared, right? X squared minus
Is it minus? Yeah,
minus
minus.
3xy, and then plus, all right, now L squared. So L is what here? No, L is what?
3y.
3y. So it's 3y times 3y,
9y squared.
9y squared. So that's 9y squared. So that's the numerator right here. So x plus 3y times x squared minus 3xy plus 9y squared. Okay? All right, so the numerator was the sum of two cubes. And so that's how you factor the sum of two cubes. Now remember, this trinomial, you can't factor, so don't even try factoring this. Nothing works. The denominator is a monomial, so leave it alone for right now. So it's a monomial with two factors. Two factors are 6 and x. Okay, now look at the numerator of the second fraction. How can you do that one?
Difference of, that's just x and,
No, you factor out H.
Come on, guys.
Factor out x.
GCF,
You can factor out H.
x. Always look for GCF first. So you can factor out an x. X times what?
X.
X minus 3y.
X minus 3y. All right. The denominator.
X minus 3y.
Tell me what it is, though.
2 cubes. I mean, yeah, 2 squares.
Difference of two squares. The GCF is 1. X squared minus 9y squared is the difference of two squares. So how do you factor it?
X minus 3y.
Very good. All right, so you factor completely. All right, so then you go through each factor and see if you can reduce it. What's the first factor you see in the numerator?
X plus 3y.
Is there 1 in the denominator?
Yeah,
Yes.
down there at the bottom.
Right here. Okay, remember, you cross them out, you put 1 to their place, because x plus 3y divided x plus 3y is 1, right? So put 1 as factors. So tell me what factor is left. The next factor you see is that trinomial. Do you see that trinomial listed in the denominator as a factor? No. The next factor you see is an x. Can I reduce anything down there? Yes, the x that's in
behind the 6.
that denominator right here. So 1's here. Now don't cross out the 6, just that x. The next factor you see is what?
X minus 3y.
So that reduces. And that's it, right? So what's the numerator of your answer?
X squared minus 3xy plus 9y squared.
Okay, and what's the denominator? 6. There's your answer. All right. So that's 58. Okay. So again, in order to succeed with this chapter, you have to know how to factor, because most of this involved chapter 6. Over 90% of what you had to do here involved chapter 6.
It's the gift that keeps on giving.
You better start being the Energizer Bunny Rabbit.
no glove, no love.
All right, now. Okay, so let's look at this now. You remember a long time ago? That's right. If you had 7 eighths subtract 3 eighths. Oh. So here I'm subtracting 2 fractions, right?
Mm-hmm.
Or I could be adding. It doesn't matter. But what do you remember? Why is this one right here easy to deal with?
Because the denominators.
All
are
right,
both
so
the same.
the denominators have the same. The denominators are the same, so it's partitioned to the same factor. So all you do to subtract or add fractions is make sure the denominators are the same. They have the same partitions, and just either add or subtract the numerators. So here I'm subtracting the numerators. So what's 7 eighths subtract 3 eighths?
4
Eighths,
One
or
half.
Which is 1/2. Okay? All right. Now, what we're going to do is use that same idea, but with variable expressions.
A whole lot more complicated.
See, I used to like even like nice little fractions.
You put in a variable, and that just throws you off.
Math.
The alphabet doesn't belong in math.
All right, so let's look at this.
Just everything Sesame Street.
All right, so this is number, it's not that difficult. This section is not that difficult, but it does still involve factoring. All right, so this is section 7.3, and this is where you're adding and subtracting. So remember the previous section was you multiplied and divided rational expressions, right? Well, not only can you multiply, not only can you divide them, but you can also do what to them? Add and subtract. So this is called
More.
adding and subtracting rational expressions. So the last section, you multiplied and divided. That was easy because all you really had to do is do the factoring. And then now we're going to add and subtract. Now this section's an easy one because you're going to notice that the denominators are already the same.
No.
Will it remain the same?
No.
Yeah.
Section-
Too good to be true.
So really the name of this section right here is adding, subtracting rational expressions with the same denominator.
So is it at least going to stay the same in this class? You know, next semester when we get, you know.
No,
No, it's the next chapter probably in this class.
no, it's a different book.
Um,
Okay, so the next section is going to be adding, subtracting rational expressions with unlike denominators. So this section's easy. You got to know how to deal with rational expressions when the denominators are the same before you can be able to do the ones where they're different. Okay, so let's look at number let's do number 6. Number 6. All right, this is on page 470. Okay, you have 8y divided by y minus 2. Subtract 16 divided by y minus 2. Don't make it difficult. What do you have? You're subtracting 2 fractions. The denominators are the same, right? So I can write this as 1 fraction. So remember when we did this one, when we did this right here, I wrote this as 1 fraction. I said 7 minus 3 divided by what? 8, right?
so it's
That's
just
what you
gonna-
did.
So it's just going to be 8y minus 16.
Okay, 8y minus 16 divided by y minus
2.
2. All right, now, the directions will say to simplify. So to simplify, all you did was just wrote as 1 fraction. To simplify, you need to factor.
Factor out 8.
So remember, you're not done with factoring. You're going to have factoring in the next chapter as well. How do you factor the numerator?
Factor out 8.
Factor out an 8. So the next step is to factor out the 8. So y minus 2 all over what?
Y minus 2.
Once you factor, see, it's the same process from the last section. Once you factor,
Yeah.
what's the next step?
And then you cancel out
Reduce. So what's the answer?
8.
Answer is 8. So that's number 6.
Concept's easy.
Yeah, now the next, notice that this section is just dealing with like denominators. Next section is unlike. So the purpose here is for you to see that the previous section still applies here. You're still using the same ideas from 7.1, 7.2. All these sections are prerequisites as you go along. So that was 6. Now let's look at 12. Okay, this is 12. All right, 12, you have 3y divided by y squared plus 3y minus 10. Subtract the second expression, which is 6 divided by y squared plus 3y minus 10. So that's what I have.
3y minus 6 over there.
All right, so now notice you're going directly to that one fraction only because the denominators are what? The same. All right, the next section, they won't be the same, so there's a couple more steps you have to do. But here, the denominators are the same, so you can go from the two fractions to one fraction. So that fraction is going to be 3y minus 6 divided by y squared plus 3y minus 10. You all agree?
Mm-hmm.
All right, so once you get to that point, what is the next step?
Canceling out.
No,
Oh,
Factor.
factoring. Okay.
how do you factor the numerator? GCF is 3, so 3 times y minus 2. How do you factor the denominator? The GCF is 1, so and it's a trinomial, so go directly to two binomials. Y, 5, 2, and then the 5 is positive, the 2 is negative. Okay, correct. All right, once you factor, what's the next step?
Cancel out all.
Right, reduce the common factors, divide out the common factors. First factor is a 3.
3.
Will that reduce anything down there?
No.
Next one's a y minus 2.
Yes.
Yes. So what's the answer?
3 over y plus 5.
That's your answer. Okay. All right. Now what we've been doing are subtraction. I didn't do an addition yet because that's the easy kind. So I just want to go directly to subtraction. Okay, let's look at this one. Let's do number 8. Number 8. All right, number 8 looks like this. All right, you have, 9 divided by y plus 9 plus y minus 5. Number 8. Y minus 5 by y plus 9. All right, so the numbers are the same, right?
Yeah.
So what I would do, rather than doing this in your head, is actually write out that step.
Y plus 4.
Yeah, you did in your head, but let's just write out that step. So that step is going to be 9 plus what? Y minus 5 divided by what? Y plus 9. Now you could have gone directly, David, into saying y plus 4. All right, but in your mind, this is what you're really saying. Now combine like terms. What is that numerator? Yeah, that's y.
Y.
Now y minus 4,
4.
y plus
So
4
you're adding 9 to a negative 5.
over y
9.
plus 9. Okay? Now the next step is to factor. Can I factor anything?
No.
Nope. The next step after you factor, in this case you can't, but anyway, you still ask yourself, can I reduce anything?
No.
Nope. So that's your answer. Y plus 4 divided by y plus 9. All right. Let's look at at 16. So 16, you have 4p minus 3 divided by 2p plus 7 plus 3p plus 8 divided by 2p plus 7. Now again, you can skip that middle step, but let's just go ahead and write it out. So I'm going to write this as one fraction. I can go directly to that one fraction because the denominators are the same. So I get 4p minus 3 plus the other numerator. What's the other numerator? 3p plus 8, all over what? 2p plus 7. So that's where I'm at. Next step, which is
7p plus 5,
divided by.
2p plus 7.
Okay. The next step would be to factor. Can I factor anything? Nope. The next step would be to reduce common factors. Can I reduce common factors? Nope. So that's your answer. Okay. All right. Now let's look at this one. This is going to be number 10. Number 10. All right. Now you have x squared plus 9x divided by x plus 7. Subtract. And then you're subtracting this rational expression, which is 4x plus 14 divided by x plus 7. All right. So I'm just curious as to what you would do this. I'm going to give you about 1 minute to work on and do it by yourself. See how far you can get. Use 1 minute and see how far you can get with this.
1 minute?
Yeah, go ahead.
That's gonna
Just-
be a limiting factor.
It would take you 1 minute to pull out your notebook. So you're subtracting this time instead of adding.